Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. So in this video we are going to summarize how to identify the polarity of a molecule. So before we can determine the polarity of a molecule, we need to identify the type of bond involved in a molecule. So we have two types of bond here. Number one is polar bond, and number two is non-polar bond. So if a molecule consists of non-polar bond, it is classified as non-polar molecule. Okay, because the electron is distributed evenly between two atoms. For example, if we have fluorine gas, okay, we have two fluorine atoms here. The electron is shared between two fluorine atoms. Okay, these two atoms are the same element and have the same electronegativity. So the electron shared between these two fluorine atoms are distributed evenly. Therefore, the dipole moment, the mu, is equal to 0. Okay, or there is no net dipole moment, therefore it is a non-polar molecule. So how about polar bond? So polar bond may form two types of molecule. Number one is non-polar molecule, and number two is polar molecule. So to identify the polarity of a molecule here, we need to identify the symmetry of a molecule. Is a molecule symmetrical or non-symmetrical? So how to identify the symmetry of a molecule? Okay, so for symmetrical molecule, which has the same terminal atom, okay, number one is basic shape, means the basic molecular geometry. So all basic molecular geometry, okay, we have 5 basic molecular geometry with same terminal atoms are classified as symmetrical molecules. Okay, so what is the first basic molecular geometry? We have linear, right? So linear, let's say we have central atom and terminal atom here. I use A as central atom and B for terminal atom. So this is linear. And then we have trigonal planar, okay, bonded to 3. So this is trigonal planar. And then we have tetrahedral, A, B. Okay, tetrahedral consists of 4 bonding pairs. And then we have trigonal bipyramidal, so A bonded to 5 bonding pairs. And last one is octahedral. Okay, so these 5 basic molecular geometries with same terminal atom are classified as symmetrical molecule. Therefore, it is non-polar molecule. Okay, non-polar molecule means the mu or dipole moment is equal to 0. Okay, but if we have basic molecular geometry with different terminal atom, okay, it will be classified as non-symmetrical molecule because the terminal atom are different. So let's say we have linear. Okay, since different terminal atom, let's say I put as C. Okay, same goes to trigonal planar. Okay, let's say we have one different terminal atom here, and then tetrahedral, C, B, B. And then we have trigonal bipyramidal, Okay, and the last one is octahedral. Okay, since the terminal atoms are different, so the dipole moment, the bond dipole cannot cancel each other. Therefore, the dipole moment is not equal to 0. It's not equal to 0 means there is a net dipole moment. Therefore, it is a polar molecule. So this is for basic molecular geometry. Okay, you need to be clear. Basic molecular geometry with same terminal atom will be symmetrical molecule and non-polar molecule, and basic molecular geometry with different terminal atom will be classified as non-symmetrical molecule and polar molecule. Okay, how about molecules with lone pairs? We have some of molecular shape with lone pairs. Okay, we have band, we have trigonal pyramidal, we have T-shape and so on. Okay, so all molecule with lone pairs is actually classified as non-symmetrical molecule. Here we have, because it has a lone pair. Okay, so band, for example, band. So A, B, D. So this is band from trigonal planar. Okay, we have one lone pair, therefore it is non-symmetrical molecule. And then if we have trigonal pyramidal, okay, there is one lone pair there, so the bond dipole cannot cancel each other, so it is molar molecule. And then we have T-shape. Okay, T-shape, two lone pairs with 3 bonding pairs. So this one also non-symmetrical molecule and polar molecule. And then we have square pyramidal. Okay, and you also have seesaw. Okay, 1, 2, 3, 4, and 5. Okay, these are 5 molecular shape with lone pairs that classified as non-symmetrical molecule and a polar molecule. So for molecule with lone pairs, we have exception for linear from trigonal, bipyramidal, and square planar. So these 2 molecular shape with lone pairs is classified in symmetrical molecule. Okay, why? Okay, let's draw the structure for linear. Okay, this linear comes from trigonal bipyramidal, where we have 2 bonding pairs and 3 bonding pairs. So we can see that this is linear in shape. So linear with 2 same terminal atoms, that means it is symmetrical. So when it is symmetrical, so the dipole moment can cancel each other. Okay, therefore it is non-polar molecule. Okay, another one is square planar. Square planar. Okay, so this is square planar. This is square. Okay, on the same plane, so it can cancel each other if the terminal atoms are the same. So this one also is symmetrical molecule and classified as non-polar molecule. Okay, so all the basic molecular geometry and molecular shape with lone pairs we have summarized here. okay, how to determine and how to identify the polarity. Okay, you need to understand this and try to memorize. Okay, I choose CF4. So CF4 is a symmetrical molecule. Why? Because the molecular shape is tetrahedral. So how we know that the molecular shape for CF4 is tetrahedral? From the Lewis structure. So the first step to identify the polarity, actually you need to draw the correct Lewis structure. Okay, followed by identify the correct molecular shape, and then only we can identify the polarity. So since tetrahedral is symmetrical, okay, why symmetrical? Because they have same terminal atoms. Okay, so since fluorine is more electronegative than carbon, okay, therefore each CF bond is polar. So polar means there is the distribution of electron is more on more electronegative atom. So here fluorine is more electronegative, that's why we draw the bond dipole here. Okay, fluorine is more electronegative than carbon. So due to its symmetrical structure, the resultant bond dipole cancel each other. Okay, cancel each other. Therefore, mu or dipole moment is equal to 0, and CF4 is non-polar molecule.